Welcome again to Wickerson Studios. My name's Michael Wickerson, and it's a couple hours till New Year's, so I thought I'd squeeze this in. I'm producing these pretty interesting forms that I'm planning on turning into metal from simple scripts. I'm just choosing to do them with a little more ability to mess with them through the C nodes that I've brought in. What you'll see is I'm using a variety of C scripts that I have brought in through, I believe, a variety of, let me just dance out of this, I believe through a variety of these Warsaw University technology places, and then usually dealing with not that one so much as the Rhino script, which should be over here as an R. So between all these nodes that I've made, there's certainly the ability to grab whatever I want. And what I've used in this script, for example, 5, is a construct tree of numbers, which is a small C script that can be followed here. And it's actually dealing with creating a data tree, which is pretty interesting because you got to use these sharp brackets. And I'm starting to read that as the final chapter in this text, which is the basic C# for 3H 3D reference in a nutshell. It comes out of the Warsaw University, so that's nice to actually be able to script and follow GPaths a bit. They're actually not that tricky, especially if you have the paperwork on it, following paths and building that as opposed to trying to follow that path through a node system. So it's nice to tuck it in there to start with a pretty interesting tree as data. So you can see when I do that I'm starting to generate this information right from the start, right out of the get-go of just 3 integer values. Then I'm going to create a sine wave. It's exponential, and I'm not sure if I pulled that from RaiISA or if I pulled that from Warsaw, if I pulled it offline. I haven't really gotten into the longer algorithms of Jose Luis, but I will. Let's take a look at this script. It's probably a little more complicated, so obviously I didn't write it, but it's one that if you take a look into it, let me just shrink it down a little bit. You can see, maybe not that small, you can see that we're playing with creating lists and alright, creating a new list, doing a for loop. The list is tucked within that one. Obviously the maths are going in there. I used to do this a lot in Grasshopper, and I found it pretty interesting, but it is nice to tuck it in here. And use sine and cosine to build your curves, and you'll find that that actually outputs the curves, the surfaces, and the breps, which is very nice because you've got this form, the curves, you've got all the surfaces that are built from those curves, all 15 of them, and you have 15 trim surfaces that come from that as well after the loft's been done between the lines. So you've got a couple of different ways of playing with it. Then I'm just going to do a list item, and actually I choose 2. Don't ask me why. I chose 2 and put them both to the same value, which is not the smartest idea, but you can see how that's going to change up the second one, and I can change the shape and size of that like crazy, which is pretty nice if I want to do that. And if I want to change the front one, I can play off of this one. You get a variety of whole bunch of different shapes. So really the sense of pairing these together, doing them in the same sand mold really appeals to me. Having a top and bottom that differs, that's very exciting to me as a sculptor, and of course I am a sculptor, and this is kind of abstract work. There's no real purpose behind this. It's just kind of a purposelessness or a disinterestedness. And then instead of using the range tool, I thought it would be fun to actually use the C# range node, which I'm going to definitely practice getting down and writing, because I'll be writing that into many things. And I like this component dot message that I see being used again and again in the Warsaw University. So you don't really have to put a group on things or use bifocals. You can write that directly into the node. So that's a real step in the right direction, at least in my opinion. So taking a look through here, you're building an interval. It's going to require a domain, which needs a start and an end. You're creating a domain, 0 being U and 1 being V, and then you can see the references are these 2 values, which then are generated, running through a double and another for loop, and the indices within that range are equal to the domain at T0 plus 1 times the domain divided by length, divided by steps. So you start to get a little bit of maths that you probably want to write these out as smaller equations with just single variable letters to kind of say, okay, is that what I want to do? Or you could just memorize all this and put it into its simplest form. But the range got used 1, 2, 3, and I used the same range tool running through for this very cool script, which is my basic single transformation. I've got a couple of transformations in here, but the main one that I'm going to be using is scale it, rotate it, move it all within one node. I think that's, for sense of efficiency, that's pretty cool. Let's open that one up and go through that. And you see right there, you've got a scale factor, a rotate factor, a translate factor, which is a transpose, which is a move. And once again, I put those through the same similar, just have to build a list so I can do that, because you have to think of your data coming in, obviously, as lists, and coming out as a tree. And because I did multiple aspects, I decided my script works nicely over here. It's an old nodal script. I don't know if I'll ever translate it in. It's a snippet tool that I use all the time to take awkward, strange surfaces and push them towards their normals. They do fudge out the corners and edges a little bit, but otherwise they do build some interesting geometries. And there's our 2, and I've got a little surface that's dancing around here. Let me put that on so I'm actually just looking at. Actually, I don't know. I guess I've clicked on something. Yeah, get it all off. But what's nice is you can change the top. The first one's the top form, forward form. The other one's the backward form. But keep in mind that I've actually baked these objects. So we can leave that. What's nice is this does not have to match up. It matches up on each one. There's symmetry on the bottoms. But what's nice, because of the different thicknesses that I'm playing with in here, actually I set them both to 2, they're going to actually have, because of different number counts, different surface edits as I go through here. At least if I take a look at that one, you'll see that I have an effect of changing the surface really nicely from no count to a full count. You can match that, or you can let it kind of step off of itself. So I think I'll leave it at 8 and let it match it. So those are pretty simple, but your scripts are getting more and more complex. It obviously would be a much longer script if I had to write these out in a nodal script. But because I'm using these basic ones, I'm trying to find out, where do I go to first? And I do like going to the point tool, but I really like within I think the C components that I did, this sense of constructing data. And actually that's one, or creating data access or types. I'm not sure where I've gotten it exactly. There's loops, there's conditionals in here that I can end up using to search with data. Obviously, I've got way too many nodes here. I've gone crazy for the last week inputting these, because what it allows me to do without plugins, I can kind of just work within my params through my display and transformation. That, and I don't really find myself going into the plugins that I was before. There's enough to do. There's enough of infinite possibilities within here. So hopefully you enjoy it. Hopefully you like the little forms. I would like to cast these. I've been making these since the start of when I was using Grasshopper. And just having this versatility to change form and to play with it and do these surface edits. These seem to be some pretty complex and beautiful forms that can be taken to print. They can be milled. They can be cast hollow, they can be cast solid, they can be changed in different materials, probably not fabricating out of steel, because they're all based on NURBS surfaces and NURBS curves, but I'm very excited about it. I do think it's nice. Let me take that other one off, and we'll take this form, and I believe it's this one. We'll just throw that through the bake, and that should be popping in there, unless it had trouble. Oh, I'm on a turntable tool. I can't believe I even left that on. It was still working. Let's just take it to a quick bake. Oh, can't bake when you're in something. Let's leave that. Now let's go to the bake. That's an old mistake I used to make. And there we go. Get a nice little bake here. And I guess I'll throw that through and analyze surface environment tool as well. And now you've got both. You've got the green, the orange, and the blue. And that one's a little too jagged. It's got too many problems as it snaps above itself. So I probably wouldn't want to do that one, or I'd thicken it. Anyway, I am sculpting away in kind of a metal casting way, deciding on what I want to do. And then it's a matter of taking it back to the foundry, where I have quite a few years of skill. So that's not really the issue. The main issue is designing these and getting what I want and understanding the logic. Because the logic that I'm following now is the geometries that I'm following, and the logic driving those geometries is not the final geometries which are being experienced by the viewer. They're actually farther back into the sense, and I think this is a great example of starting a project with construct tree of numbers. Let's start with numbers and the attributes to those and the paths of those, the branch, the trees, the branches, the items at the ends of each ones. So very nice form. I think I'll do a lot of scripts with this to begin. Hope you enjoyed it. 10 minutes. Happy New Year.